Welcome to the Alpha Training and Consulting's online training program. Today I'm going to answer the question, what is an alternative hypothesis? Okay. Remember, the hypotheses must cover 100% of all possibilities. We talked about that last week. As a result of this statement, each inference study uses two hypotheses. If you consider the first hypothesis to be the null hypothesis, remember, just a review from last week's lecture, the null hypothesis must have an equal sign. Then the second hypothesis will be referred to as the alternative hypothesis. So let me give you just a second. If this is the null, what would the alternative have to be to cover 100% of all possibilities, cover the whole number line, for example? What do you think that would look like? Okay, let's go to the next slide and see what that will look like. So the null hypothesis is x bar 1 equals x bar 2. Oh no, that's a mistake. I threw it in there on purpose so I can let you know that you don't do that. This should be mu 1 and mu 2. You don't use x bar in hypothesis studies. You go mu 1 equals mu 2. So this would be incorrect. I tell you that because sometimes they may test you on that on an ASQ exam, say, which one of these is a null hypothesis? And they'll have some that don't have an equal sign. One will say x bar 1 equals x bar 2. One will say mu 1 equals mu 2. This would be the correct one. This would be the correct one right here. This would be incorrect because it says x bar should say mu. Remember, it should always be talking about the population. X bar talks about samples. In hypothesis testing, I don't care about samples. I want to know if the populations are different. And thus, you should always use the Greek symbols to represent populations. Very good. This leaves only one option for the alternative hypothesis. Remember, this is the null equal. Then the alternative hypothesis for this null hypothesis will be mu 1 does not equal mu 2. So there you have the null hypothesis and the alternative hypothesis. You put those together, it covers 100% of all possibilities, which is what it says right here. So the null hypothesis, mu 1 equals mu 2, plus the alternative hypothesis, mu 1 does not equal mu 2, covers 100% of all possibilities. Remember, the normal distribution only needs two numbers to describe it completely. That's the average and the standard deviation. So these could also be replaced with sigma, standard deviation there also. So keep that in mind. It just depends on what you're studying. All right, this table shows the possibilities for hypothesis pairing. So if you choose this as your null hypothesis, then it's mu 1 equals mu 2. The alternative hypothesis has to be mu 1 does not equal mu 2. By the way, this is a two-tailed test that we'll talk about in later lectures. Okay? And mu 1 is greater than or equal to mu 2 is another possible alternative. Remember, it just has to have an equal sign. Those have equal signs. So mu 1 is greater than or equal to mu 2. Then the alternative hypothesis must be mu 1 does not equal mu 1 is less than mu 2, covers 100% of all possibilities. This would be what we refer to as a one-tailed test because we're just looking at one side of the distribution. All right, and the next one is mu 1 is less than mu 2, less than or equal to mu 2. Then the alternative hypothesis must be mu 1 is greater than mu 2, and that will also be a one-tailed test because it's just looking at one side of the distribution. We'll get more into one-tailed and two-tailed tests in a separate lecture. So there you go. We've discussed now null hypotheses and alternative hypotheses. This is the language of the hypothesis studies. Notice in these lectures we don't talk about any math. This is just the language of inference studies or hypothesis tests. So if it's statistically significant, we would say, I have enough information to reject the null hypothesis. I have enough evidence to reject the null hypothesis. What does that mean, reject the null hypothesis? Null hypothesis mean equal, so when I reject it, I mean it's not equal. Why don't they just say not equal, John? I don't know. I didn't make up the rules. I'm just telling you the rules. And so that's how it works. You either, if it's statistically significant, p-value is less than alpha risk, then you would say, I have enough evidence to reject the null hypothesis. If it's statistically insignificant, p-value is greater than the alpha risk, then I would say I do not have enough evidence to reject the null hypothesis. So there's two options. I either have enough evidence to reject the null, not equal, or I do not have enough evidence to reject the null hypothesis. And that's the language of hypothesis testing. And so you should become fluent with this language so you can communicate with everyone else involved in your organization. Why do you need to do this? Because to be successful in your career, you need to create credibility. And understanding how to speak this way helps you with your credibility and allows you to communicate with others on the team. So there's the reason. All right, there you go. We finished that lecture. Hopefully you learned something there. Now, if you have any questions, please contact me. I'd love to hear from you. And also, keep us in mind for any of your ASQ certification preparation needs. And I have a website for our various classes here. And for example, CQE is www.asqcqe.com. If you're interested in any of these other classes, please take a screenshot and go to that later and learn more about that class. We'd appreciate your consideration. Thank you, and have a great day. Goodbye.